Okay, good morning students. As you know, my name is Sudh Pandey and you are floating with me in the world of physics. We are going through a chapter and the chapter name is your fluid mechanics. So in that chapter I have completed your introduction that why we are in need of to study about the fluid mechanics, and after that we have gone through a property that called the pressure, and we have also discussed about that the when one move from one point to another which is in the vertical direction, then the pressure changes by an amount of rho gh. Okay, so what we have learned up to here, we have learned that if we have any, we can say that we have any point, okay, and the 2 points are at the certain separation in the vertical direction. Okay, what does it mean? It means simply that if we take a container like this way, suppose this is the container, we can simply say that this is your container. Okay, let's suppose, okay, and we take a point, let be the point be A, and we take another point, let the point be capital B. Okay, so these 2 points are in vertical plane, so this is the vertical direction, we can simply say. Okay, so if the separation between these 2 points let be H, then we can say that the pressure at point B will be the pressure at point A plus that H rho G. Okay, it means the pressure on a point which lies deeper inside the liquid is more and increases by an amount of rho gh. Okay, so we are talking about the points which are in the vertical plane. So I hope that that lecture was completely understandable for you. Okay, now what? In this lecture, we will discuss about the pressure at the same level. What will happen if the points are at same level? What does it mean? It means we simply want that we have a container, let be, okay, as you can see in the diagram shown here. But now the condition is that we have a point A, this be your point A, and this be your point B, and both are at the same level. Okay, so as in the previous lecture we have discussed about that due to the pressure there is a force. So basically we have the pressure and that is force per unit area, and due to this pressure we have a force that is P cross A. Okay, so what is A? A is the area of the cross section. So here, as I have already told you, that we consider the fluid as an ideal fluid. Okay, so we take about a point, and that point is covered by a cross sectional area. So here the point A is covered by the cross section area delta S1, and the point B is covered by the cross sectional area that is delta S2. And we know that in the very previous lecture I have already told you that the delta S1 delta S2 are taken as equal, and that become delta S. So if we talk about the pressure at point A, or we can say the force at point A, so by using the basic formula which is written here, we have for point A, we can write down that the force Fa, that will be pressure Pa into delta S, because delta S1 and delta S2 both are equal, and let be delta S, so it may be equation number first. Okay, similarly if we talk about the point B, then let's see what will happen. So for point B, so if we have point B, then again by using the same formula, that will be FB, that will be pressure at point B and into delta S. So The question is, as in the previous lecture, we considered that the liquid column is in equilibrium. So here also the liquid column, and the liquid column which is in horizontal direction. Clear? Horizontal direction. So earlier we have discussed that the liquid column is in vertical direction. Okay, but here the liquid column in horizontal direction. So we can easily see that this is your horizontal liquid column, this is your point A, this is your point B. It means simply say that that will be the force at point A and that will be the force at point B, and if the liquid column is in equilibrium position, because either the column is in vertical direction, either the column is in horizontal direction, but the fluid is at rest. That is the basic thing. So if the fluid is at rest, then we can simply say that the liquid column will be in equilibrium. So liquid column will be in equilibrium. So if it is in equilibrium, then what will happen? So all the forces must be equal and balanced. So we can simply write down that FA must be equal to FB, and what is the value of FA? That is PA times delta S. And what is the value of FB? That is PB times delta S. And delta S cancel out, and we get a final result that PA equal PB. So this is very important result. What we get that if we talk about the vertical column, it means 2 points which are in vertical direction. Once again, let be the point A, that point B, that is in vertical column. So the separation between these 2 points be H. And on the other hand, we have 2 points which in the horizontal column, that is point A, that is point B, and let be the separation again H. So if we talk about the vertical column, then we have the pressure at point B, that will be equal to pressure at point A plus H rho G. But if we talk about the horizontal column, then we have pressure A, that must be equal to pressure B. So that is the important result what we have covered up to here, and I hope and believe that each and everything is clear to all of you. Okay, so the journey will continue in the same pattern, in the same matter. I hope that you are enjoying the lecture. Okay, now what we will discuss about the Pascal's law. Pascal was a great scientist, as I have already told you that on the honor of the Pascal, the SI unit of pressure is also taken as the Pascal. Okay, so it is obvious that he played a very huge role in the contribution of the fluid mechanics. So what Pascal told, what Pascal analyzed, that each and everything we will discuss here only. Okay, so first thing what we have noticed that we know that pressure difference between 2 points, pressure difference between 2 points in a liquid at rest depends only on the difference in the vertical height between the points. Okay, so I hope that this thing is very clear to all of you, that if we move in the vertical column, then only there will be a pressure difference. Okay, once again, in vertical column, you know that point A, that point B, so the difference in the pressure will be H rho G. So this thing is clear. Okay, now suppose by some means the pressure at one end of the liquid is increased. So the basic thing is there that we have pressure at point B, that is PB, minus pressure at point A, and that must be equal to H rho G. This thing we have calculated, we have derived very earlier in the previous lecture. Okay, now the main point is this, that if we increase the pressure at any one point, let be we increase the pressure at point A, and the pressure becomes PA dash. Okay, but the scene is this, that this must be remain same, so it will be H rho g. That minus will remain same, so what should be here only? It means we can simply say that the pressure at point B automatically changes and becomes PB dash. So PB dash minus PA dash, that will be also equal to H rho g. So that is the very interesting feature in case of the fluid at rest. Okay, so if anyhow by any mean if we increase the pressure at one point, then automatically that pressure increases on each and every point within the liquid column. Okay, so I hope that this thing is very clear to all of you. Now what we will see, the statement of the Pascal, what Pascal told us. According to Pascal, if the pressure in a liquid is changed at a particular point, the change is transmitted to the entire liquid without being diminished in magnitude. Diminished means without decreasing its magnitude. Okay, so what actually Pascal wants to say, that if we have a column like this way, okay, and firstly we have this flask like this way. Okay, this, let's suppose this is the initial situation. Up to here liquid is there like this way. Okay, we have 2 points in the vertical column. Let be that be point A and that be point B. So initially we have pressure at point B minus pressure at point A, that must be equal to H rho g. And what is H? H is the separation between these 2 points. Okay, now what? According to him, if we apply an external force, so here we have applied an external force. Because we apply external force, so we know very well that pressure is nothing but force upon area. It means if we apply, it means we are increasing the force. And if we are increasing the force, keeping the cross section area constant. This is the constant as you can see in the picture. Okay, so this is your cross section area and that is constant because the flask is same. Okay, so we can simply say that F directly proportional to pressure, and if we increase the force, then pressure also increases. It means in the second scenario, in this case, we have the pressure at point A that will also increases and becomes PA dash. Okay, so the question is that if we have PA dash in place of PA, then what should be the value of PB? So PB must be changed because the difference is always constant, which is H rho g. That's why Pascal states that when we increase the pressure at one point, then it will be changed the pressure at each and every point within the liquid. Okay, and the pressure that is transmitted will not diminish. Okay, will not decrease in magnitude. If it decreases, then the difference of the points PB dash minus PA will not equal to H rho g, which is not possible. So I hope that you now in the situation that you can better understand what actually Pascal told us. Okay, so now what we have some interesting application which follows the Pascal's law. As you can see in the picture that we have a hydraulic lift. Hydro means fluid, we can simply say. It means by using a fluid we make a lift which is used to raise heavy load such as car. Okay, so the basic thing is that this is your column, or we can say that U-shaped structure, and in that structure whatever fluid is there, that fluid is we can simply say that at rest. So this is the fluid Okay, this one as I have drawn like this way. Okay, so this is the basically your fluid, and the fluid is at rest. So this thing is very interesting, that the fluid must be at rest, then only you can apply the Pascal's law. Now what? Now we will have, we can say that we have here two vertical columns. Let be this one is your first vertical column, like this way. This is your first vertical column. Okay, and let's suppose the length be L1, and the second column, that let be this is your second vertical column, and also we have the length, let be L2. Now if we decrease the value L1 minus L2, then we have a certain length, maybe L or maybe H, whatever you can take. Okay, so what we are actually doing here, that we are in need of draw a level. So this is your level, we can simply say that. Okay, so if this is your level, so this will be basically the length L, because L we have taken here. Now the interesting thing is that we have already told you that if we have a liquid column. So firstly let's see for first column. So for first column we can consider that this be your column, as you can see in the picture, and the area of cross section is given to A1. Okay, and this is the level what we have taken here, and this one is the length L, let's suppose. Okay, let be that is the point A and that is the point B. It means the pressure at point B will be nothing but that will be equal to pressure at point A plus H. So H will be L, so L rho G. So this is for, basically we can say that this is for the first column. Okay, now if we talk about the second column, so if we talk about the second column, so second column we have this one, we can simply, you can see in the diagram, and the area whatever is given, that is A2, and let be the point B is there. Okay, so we have directly we can write that the pressure at point B, that will equal to L rho G. Why? Because these points are in the same horizontal level. Okay, so if the points are in same horizontal level, so for column B, if we, let's suppose the point name P. Okay, no, P represents the pressure, so we will take another point, let be point S. Okay, so this will be point S, so that will be point S. Okay, so pressure at point S, that will be L rho G. Now what? As we have discussed that at same level the pressure must be same. Now we are in need of to apply the force. When we apply a force F1, then what will happen? Because according to Pascal, firstly I will rough this one, and then we will discuss what is the impact of the force which is applied at the sectional area A1. Okay, so basically if we apply force on section area A1, so we have simple, we have that the pressure at point A. So pressure at point A, that will be the force, that will be F1, and the area, that is A1. I think and I suppose that it is clear. Now if we talk about the pressure at point B, so the pressure at point B, that must be the, let this one we have taken point A, let be this be point S. Okay, this be point S, this is point A, this is point B, this is point S. So if we take the point S, okay, so point S, that will be equal to the pressure at point A, and plus we have L rho G. I hope that this point is quite easy to understand. Now the pressure at point PS, it means point S, that is equal to the pressure at point B. And why? Because they are at same level. So we have the pressure at point B, that is pressure at point A plus L rho G. What does it mean? It means if we increase the amount of pressure at point A, then also the pressure at point B also increases by the same amount, which is equal to F1 upon A1. Okay, so if we only talk about the pressure at point B, so we have that pressure at point B, that is your force at point B. Let's suppose that is F2, and the area, that will be A2. So the scene is quite easy, that we have a condition that the pressure at point A should be transmitted to pressure at point B. So we have here that what should we write? We should write that according to Pascal, whatever pressure is given to point A, that must be transmitted to point B. Okay, so that will be F1 upon A1, and that will be F2 upon A2. So basically F2, that will be equal to F1 upon A1 times A2. So that is the very interesting things that you can see in the diagram. This is the basic diagram. Okay, so if we apply a small force F1, then as we have that this pressure PA will increase by length, or we can say the vertical column L rho G. It means the final pressure at point B will automatically increases. And when we increase the value of pressure at point A, in the same amount the pressure at point B also increases. So we have that according to Pascal, whatever amount of pressure increases at point A, that amount of pressure should be increases at point B. Okay, so that is we are talking about the amount of we can say the amount or magnitude of the pressure which is increasing. Okay, so whatever amount of pressure increases at point A, the same amount of pressure will be increased at point B. And also we have a result that the pressure difference must be same. It means only a small amount of force at column A here can be result the great force at point B. And that's why very easily, or by applying a very small amount of force, one can easily lift the car. You can imagine a car have quite much weight with compared to the force which is applied by any person. Okay, so this is the very interesting result. You can also calculate the result from the observation or final formula what we have here only. Okay, so you can clearly see that the A2 that is quite greater than E1. Okay, it means we have a result that F2 will be quite greater than F1. So that's why I am saying that if we apply a small force, then the resultant force, or we can say the final force which is applicable on the point B, that will be so huge in the amount. So I hope and I believe that up to here each and everything is clear to all of you. Okay, so we will meet in the next lecture. We will continue your journey in the same pattern. So thanks for watching me, thanks for listening me, and the best of luck to all of you. Thank you.